welcome to part 2 of my Beast Car body design videos. I'm going to be showing phase 2 of the CFD work that I did, the detailed CAD work, and also you can have a bit of a laugh at some of the weird designs that I came up with along the way. So let's get into it.
So following on from phase 1, my goal was to reduce the sensitivity of the body shell design to any changes in pitch, and I decided to just try a few things to see what might give an improvement. First thing I tried was adding these little flicks on the front lower edge, which are called vortex generators, and I also vented the tops of the wheel arches. Let's have a look at this with the particle tracing on. So you can see that it does actually change the direction of the airflow as it goes around the front of the shell there, and it helps pull a bit of air out from the front of the front wheel, which could reduce that high pressure zone, which is actually trying to lift the front wheels off the ground. So it was looking kind of promising. We'll have a look at how it actually performed on the results in a minute. Next one I looked at was something a bit more traditional in terms of speed car layout. You know, this is this sort of bulbous front region is a bit reminiscent of the Le Mans style bodies that a lot of people are using really on the speed running. So I thought I'd just give that a try and see if that offered any benefits. But you can see here it's not looking good really from that big area of low pressure, that light blue colour showing there. What did I try next? Next I tried what's called a canard, which is like a small front wing type device that sticks out the side. You might see these on some more sporty cars. I mean, you might argue they're just for looks more than aerodynamics, but they are used on some time trial cars as well for actual aerodynamic performance. My thinking was that this could give a bit of extra downforce, but without being too sensitive to the pitch angle, not like a splitter, which I think would be more sensitive to pitch angle. And from the particle tracing, you can see that a bit like those vortex generators, it was successful in pulling a bit of air out from underneath there. It's generated some low pressure underneath it, which will help give a bit of front downforce. And it's interesting because you can actually see the air that's churned up by it as it goes through the air there. So yeah, I think that's particularly interesting. Let's have a look at the results for those. So firstly, I've got a bit of a reminder of where I was with the previous design. So this is where I was getting concerned about the sensitivity to the front getting raised, because my nearly 4 kilo of downforce on that run went to nearly 5 kilograms of lift on the front. So my phase 2 results then for the runs that I've just showed you, neither the vortex generators or that, particularly actually the sort of bulbous front end design, neither of them showed any benefit. In fact, they got worse in terms of front downforce, so that wasn't looking good. The canard design, that did show an improvement though of around 1 and a bit kilograms. So that was looking promising. So I tried what would happen if you put an extra one there, and that made it go worse again. So it seemed like just having that single front canard could be a way forward for me. So I went on to explore that in some other runs. And just to prove that whether it worked or not, I did a run both with it and without it at static sag this time. I didn't mention, but all these runs I did before that, they were all with the front raised. And what that showed was that there is definitely a benefit of having that canard on the front. It generates around 3 kilograms more front downforce in comparison without having it. But this raised a bit of a question because I seem to have lost all the downforce off the rear as well in this run. So this is where I started finding my CFD results a bit confusing and a bit contradictory of what I'd got previously. I mean, it's difficult because I had made some other changes to the design as well. Like I had hollowed out more of the inside of the body shell to better represent the airflow. So maybe it was that was having that effect. But it was sort of hard to know exactly what had caused what, because I hadn't done it all just step by step, changing only one thing at a time. So finally, I did go back to one of my earlier models and add the canard to that with the front raised. So I think this was showing that the canard does seem to be having a benefit again, because the earlier model it was showing, I think, minus about 4 kilograms in this condition, so it's about 3 kilograms better than it was before. And then in the static sag condition, this run here, it's showing quite a good balance front to rear, but again, some of the downforce seems to have gone that it had before. It used to have nearly 4 kilograms front and back, so where's that gone? Is that just from adding the canard? It seems sort of unlikely. And then finally, I made a bit of a change to that model and connected the wheel arches. Um, and also I changed from a single central fin to the fin on each side. So again, I made the mistake of changing two things at once. So it wasn't totally clear as to why I'd then lost most of the front downforce. I think that's probably mainly because of the wheel arch modelling, though, because I think I'd changed between single and dual fins in the past, and it hadn't really made much difference. But at this point, I'd basically run out of CFD runs, because you only get so many free runs on Simscale, which I was using to do this work. And I'd also run out of time. I just had to freeze the design so that I could finish all the details of it, so I was ready to manufacture it. Before we move on, let's have a quick look at a couple of the designs that didn't make it, um, that just look a bit look a bit weird. So here's one I tried where I thought it might be better to try and push some of the air around the sides of the car rather than over the top, because I found, if you try and push the air over the top, it speeds up and generates low pressure. So that was my thinking with this one, and I've also thrown in a bit of a splitter effect and the Diesel Max underfloor style. Um, Unfortunately, this was just so bad looking that I didn't even try it. Maybe I should have tried it. Who knows? I've got another one as well, which is quite funky. I was finding that there was a bit of a high pressure zone underneath the front of the car and low pressure on the top. So I thought, why don't I just join the two together? Hence, I made this sort of weird air channel that went from the bottom to the top there to try and reduce that effect. Unfortunately, I didn't find any benefit from that. I mean, you can also see it's got a sort of air deflector thing in front of the front wheel, and again, I found that didn't work. It, instead of getting high pressure on the front wheel, you just got it on there instead, so it just moved the problem somewhere else. Anyway, it's a bit of a light-hearted look at a couple of the designs that fell by the wayside through the development process there. I'm going to show now why I had to freeze the body design and its shape, and I'd run out of time to do any more work on the CFD, and that's because I had to add in so much detail to it to be able to 3D print it and make the body shell. Because what I'd been working on previously, it was literally just the outside shape of it, none of the internal details, how it was going to be made and joined together was there. So this is what I'm going to show now. So this is actually the final assembly. I'm going to do a bit of a CAD spin of this and just go through it piece by piece. So let's start at the front. So if I can hide off the other bits in here. There we go. So this is designed with 3D printing in mind. So it's printed with this face on the build plate. It's got mounts for clip nuts to allow it to be attached to the carbon fibre plate chassis. And I've designed it with the lighting system in mind. So I decided to use a LED type lighting system. If I just hide that front piece, you can see that. So this is the LED itself. It gets to attach to this piece of aluminium L section, a material that you're familiar with from my other videos probably. that's there for heat dissipation. I was worried without that it would get so hot that it would start melting the 3D printed plastic around it. So by having that there, it spreads the heat into that and gives it more surface area to sort of for the heat to go away into the air from. With the front hidden off as well, you can see how the canard goes in. The canard itself is like a 3D printed piece that goes into a slot in the main front end part. There's a little recess here actually. This is interesting because I can then cut a thin bit of polycarbonate, glue it into that little recess, and then I've got a fully faired in light system, which will be the best for the aerodynamic performance. Those are the main features of the front end there. You can see there's a little retention screw there for the canard that I didn't mention. So let's look at the middle now. The middle's made of 2 pieces, which are quite large. Like this is over 300 millimeters long. Each of these sections. So you'll see in my next video that they needed a special 3D printer to make them because they're so big. I've added mounts along the sides. That's what these holes here are for. So they go on the screw on those ones. It goes through the body shell and into a clip nut on the chassis. I added these longitudinal ribs to give extra stiffness and strength, and you can see they're joined in the middle there with that sort of mounting flange thing. That also gives it an area to sit on the 3D printing build plate. So they're built from this face upwards. Again, you'll see a bit about that in the next video. These 2 sections are actually quite similar in sort of how they're designed. Just the only exception is this rear part has got a couple of holes for the 2 aerials I've got on the car. So if I hide off all of them and put the rear on, the rear's on. Hide off the other ones. Yeah, there we go. Interestingly, I've got a fin showing in the middle there. Early on, I was thinking of having several options for the fins, like either having one in the middle, one on each side, or even 3 fins if I wanted to. But in the end, I decided to scrap off the middle fin because it was interfering with my idea for the light layout of this rear end section. So I'll just get that off the thing there. So the fins themselves, they're actually held on with a couple of screws that go through there, which I think is quite a neat way of doing it. They've got like just a slot in that allows the screw to go through at an angle, which is quite a neat way of holding it on, I thought. Again, I've got a aluminium bar here that the LEDs go onto for heat management. That's then screwed into the 3D printed plastic of the body, but with an air gap. The aluminium isn't directly bolted to the 3D printed plastic there. There's a little hole here that's for the switch for the light system, and I've also got the clip nut mounts that you saw at the front and a little recess for the light wiring there. If you're wondering what these little holes are, they're actually for some connecting rods that goes between each component. So if I hide off the rear, show the middle again, you'll see the corresponding holes on those ribs. That one obviously had to be offset to allow for the aerial mount there. So I'll just use some rods to just help with the alignment when I'm gluing the parts together, because my plan was to epoxy these components together. And there's a little bit of an overlap as well. You can see it there. There's this sort of extended piece that overlaps with the next piece to give a bit more area for gluing and help it be held together securely. So there we have it. That's a bit of a whirlwind tour of my detailed body design, and it was something that I had to achieve in quite a short space of time. I'm quite pleased with how it went actually. So before I knew it, I was then starting to 3D print these pretty massive bits of body shell that you'll see on the next video. let's have a look at where we got to against the requirements that we started out with. So in terms of frontal area and drag coefficient, the frontal area was minimised. The chassis was optimised to make it narrower, which minimised the frontal area. The drag coefficient that I ended up with was 0.22, which is actually pretty good. Thinking back to the previous video, there weren't many cars that were achieving that. In terms of balanced downforce, there's some unknowns there, as we saw. Some confusing results mean I'm not entirely sure whether I've managed to achieve that one or not. So that one is a question mark. I'm trying to mitigate against potential issues with that by having different size canards to potentially run the car if I do run into issues. And I could potentially make different versions of the body shell with more or less downforce at the rear. So space inside the chassis for tyre clearance, I made sure that there was at least 5mm sideways and 10mm plus in the radial direction to give plenty of room for any tyre expansion or suspension movement. So I think that's a tick. And how tolerant it is to ride height and attitude variation. Unfortunately, that also falls under the category of not entirely sure. We'll have to see how it goes from testing and use the testing parts if necessary. For directional stability, it is something that I could have tested for in CFD by running the whole body shell. Like instead of running half the body shell, I could have run the whole one with it at a slight angle to the airflow, and then see if it generated a sort of turning force to make it go more into the airflow or away from the airflow, which would be bad. But unfortunately, as I mentioned, I ran out of time and CFD runs to be able to do that extra study, so I don't know where I am with that. But again, I've got different test parts to allow some tuning if I need to. I've got different height fins that are going to affect that aspect and allow me to tune it if I want to. Lighting system, I provisioned for that in my detailed body design. As you saw, I've got the fully fed in front lights and the rear lights there with the switch provision, so that's all there. And ease of manufacture, I did carefully design it for 3D printing in mind. I even designed it so that it would minimize the amount of support material necessary to make the parts, and you'll see in the next video the manufacturing of these parts. That the support requirement for that was optimized. And finally, strength and stiffness. I did what I could to make the parts as strong as possible. You could see the reinforcing ribs I added to the two middle sections, and the front and the rear sections of the body are almost solid. I mean, they won't be 3D printed solid, but because they've got that they're fully enveloped. That will make them stronger. So I think I'm looking okay on. I've been forgetting to tick these off. So yeah, there was a question mark on directional stability. We can tune that, and then the other ones are achieved. So not a bad result.
So as you'll see, I got to my final body design eventually. It was a bit of a journey along the way, and I had a few learnings. And the first one was that in doing the CFD, don't change too much at once. Like I found that if you change basically more than one thing from one run to another, you won't really know what caused any difference in results that you see. So that's my first top tip. My second one is to just keep your CAD model simple when you're doing the CFD, but it should model the key airflows, like I mentioned towards the end of the CFD, that I connected the wheel arches up, and by that I meant I connected the front and the rear insides of the body shell, because in reality air can flow through that region, so that should be captured in the CFD model. The final one is just that generally it takes a lot of runs to fully understand what you're working on in CFD. Unfortunately, I didn't have that at my disposal. I had a limited number of runs because I was using the SimScale free plan where you get 10 free runs. Maybe it's best not to start down the journey of doing CFD unless you can have access to a lot of runs to enable you to fully explore your designs and fully understand them. Hold on, that was a bit negative. I don't want to end the video on that kind of note. So to put a bit of a positive spin on it, SimScale is a great tool, and it's so generous of them to give us 10 free runs to use as we want. And within that 10 runs, I think you could get a good understanding of whether your proposed body shape works or not. Where you might find that you run out of runs is if you want to then develop that and explore different options. It's also worth mentioning it's hard to know how accurate to real life the results are unless you were to take your car to a wind tunnel and measure the front and rear downforce and the drag with load cells. We'll never really know. So that's why I think we can definitely count on it as a general guide, but maybe less so for the precise results unless we're going to do some more advanced correlation type work. I'll be back soon with another video which is going to show how I went about making the body shell. Keep an eye out for that one coming up soon. In the meantime, please like, subscribe and share the videos if you know anyone that might find them interesting. I'd really appreciate that. Thanks for watching.